Yes, welcome back to the session. In this video, I'm going to discuss about relation between linear velocity and angular velocity. Okay, so look at this diagram. There is a particle of mass m which is moving in a circular path. Okay, so let us assume here the particle is moving in anti-clockwise direction. Okay, so initially the particle is located at point A whose radius vector is r from the center O. Now the particle is moving from A to B in this direction. That means it covers some distance s and it makes an angle theta with respect to the radius. Okay, so whenever it makes an angle theta, we know that the basic formula in mathematics, theta is equal to arc by radius, right? So theta is equal to, here arc is nothing but s by radius means r. So theta is equal to s by r. From this, s is equal to r into theta. Let us assume this is equation number 1. Okay, so please remember, whenever a particle is moving in a circular path, it exhibits two types of displacements. So in a circular path means we have two types of displacements. Okay, so one is linear displacement. So here one type of displacement is linear displacement and the other one is angular displacement. Angular displacement. Okay, so whenever linear displacement was present, definitely there must be linear velocity also present. So therefore linear velocity also present, and similarly due to this angular displacement, angular velocity also present. Angular velocity also present. So in a motion in a straight line, we know that linear velocity means v is equal to ds by dt. Let us assume this is equation number 2. Okay, similarly angular velocity means omega is equal to d theta by dt. Let us assume this is equation number 3. Okay, so in equation number 2, v is equal to ds by dt, but we know that s is equal to r theta, right? So you can substitute here. Therefore v is equal to d by dt of s means r into theta. So this equation we can write it as r into d theta by dt. Okay, so here d theta by dt means omega, right? Therefore v is equal to r into omega. Okay, so this is the relation between linear velocity and angular velocity. Okay, so after getting this linear velocity and angular velocity, we can calculate linear acceleration as well as angular acceleration also. Let us see. In the case of linear acceleration, so linear acceleration means a is equal to dv by dt. Okay, so here d by dt of v means r omega. Okay, so I am going to substitute here r omega. Okay, so a is equal to r into d omega by dt. So, so here d omega by dt is nothing but angular acceleration alpha. Therefore a is equal to r into alpha. So I hope you understand. Thank you so much.